good day. This is Group 1 will present a Deadlock and Starvation algorithm. And the member of the group, welcome Christian Luis MALIG-ON, RAFAEL SINGGA, LUIZ LUGSANAY, DOLPH, Brian BITOS, OMAR YUSOF PILA, JAYLA MONARES, TRISTAN FLYNN LABRADOR. So here is the objectives of the deadlock. So define what deadlock is and explain the condition that can cause it to occur. To implement deadlock algorithm in C language programming. To explain the advantages and disadvantages of using deadlock algorithms. Continue of the objective to provide an overview of the concept of starvation in computer operating systems, to introduce strategies for preventing starvation, and to implement starvation algorithm in C programming. So deadlock. Deadlock occurs when two or more processes or threads are unable to proceed because each is waiting for the other to release a resource. In other words, it is a situation where two or more processes are blocked forever, resulting in a system-wide halt. So, in scenario natin gitawag nga duha ka process o duha ka resource, natin process A and B, then nasa tayo resource 1 and 2. Then each process need to acquire the two resources, which is the 1 and 2. Then in this scenario kay si process A ni acquire sa resource 1 ay si process A ang lagi, then si process B ni acquire sa resource 2. Then need man jud nga each process mo acquire sa resource, then si process A mo try og acquire sa resource 2. Then but dili niya ma-acquire kay lagi gikuptan na siya sa process B. Process same goes po sa process B mo acquire siya sa resource 1, then din na sad pwede kay gikuptan na sad sa process A. Then maghuwatan na sila nga i-release, pero di man mabuhat nga mo-release kay lagi need man nila i-acquire ang duha. So mo na resulta stock or mo na gitawag nato nga deadlock. So mo ni matawag sa deadlock if ma-meet niyang upat ka condition: mutual exclusion, hold and wait, no preemption, circular wait. So mo ni mutual exclusion, at least one resource must be held in a non-shareable mode. Hold and wait, process holds at least one resource and is waiting for additional resources that are currently being held by other processes. No preemption, resources cannot be forcibly taken away from a process. They must be released voluntarily. Circular wait, there is a circular chain of two or more processes where each process is waiting for a resource held by the next process in the chain. So next reporter, please.
So good day, everyone. These are the advantages and disadvantages of deadlock algorithms. First, avoiding system failures. Deadlock algorithms help avoid system failures due to resource unavailability. Without a deadlock algorithm, resources can be blocked and become unavailable for a long time, causing system crashes. The second one is efficient resource utilization. Deadlock algorithms can ensure that resources are used efficiently, which can help improve system performance. By preventing deadlocks, resources are available for processes when needed. And the third one is increased system reliability. Deadlock algorithms can help increase system reliability by preventing deadlocks that can cause system crashes or freezes. By preventing deadlocks, the system can continue to operate smoothly without disruption. And these are the advantages. First is overhead. Deadlock algorithms can add significant overhead to a system. Deadlock detection, for example, requires the system to periodically examine the resource allocation graph, which can be time-consuming and resource-intensive. And the second one is complexity. Deadlock algorithms can be complex to implement and maintain. Deadlock prevention, for example, requires careful monitoring of resource allocation usage, which can be difficult to manage in complex systems.
So to proceed, we have here a sample deadlock scenario in a deadlock, a program in C which simulates a deadlock scenario. So first is we have here the two headers. So these are include statements for the standard input, output, and pthread libraries. So this is the header, as we all know, which is the standard input, output.h and the pthread.h. Next is we have these two lines, which declare the two variables of type pthread, mutex t called mutex A and mutex B. So these variables will be used as the two mutexes that the threads will try to acquire. Next slide, please. So next is we have here the function, the void function. So this is the code for the first thread, thread A. It is a function that takes a void argument and returns a void value. Inside the function, we have here the pthread mutex lock, and inside it, in its parameters is mutex A, and it attempts to acquire mutex A. So if successful, it prints a message saying that it has acquired mutex A, sleeps for 1 second to simulate doing some work, and then attempts to acquire mutex B. If successful, it prints a message saying that it has acquired mutex B, and then it unlocks mutex B and mutex A. Finally, the function returns to null. So in this function, we try to acquire a thread tries to acquire a mutex. So this is the mutex lock, and then after that it will print a message, and it will then sleep in order to simulate some work, and then next it will then try to acquire a second mutex, which is B, in order to fully satisfy the condition, in which after then it will then unlock the two mutexes. And next slide, please. So the next function is thread B. So it is quite similar to the first function, but the only difference is that this function first tries to acquire mutex B instead of the first function, which tries to acquire mutex A, and so on and so forth. Next slide, please. So this is the main function of the program. It declares two variables of type pthread t called tid A and tid B, which will be used to store the thread IDs of thread A and thread B. Next line is we have pthread mutex init or initialization. So this is where we initialize the mutexes A and mutex B. Next is we have pthread create, which will then create two threads respectively, and then the thread IDs are stored in tid A and tid B respectively. Next is we have the pthread join and pthread join B, which will then wait for thread A and thread B to finish proceeding. Next slide. Then finally we have pthread mutex destroy. So the last line of code will, the second to the last line of codes will then try to destroy mutex B's in order to free up resources. And then lastly, it will then return to 0. So next slide, please. So once the program is successfully executed, it will then try to show this output. So thread A acquired mutex A, thread B acquired mutex B, and then thread A trying to acquire mutex B, thread B trying to acquire mutex A. So this is the example of a deadlock scenario or phenomena in which a thread is trying to acquire another thread but fails to do so because another thread is currently using up a resource or a mutex in this case. So in this scenario, each thread has a circular, or each let's say process has a circular dependency upon the other, and it will then it is forever stuck in a loop because each thread is waiting upon the other for waiting for the other thread to release the mutex in order to satisfy the condition. So this is a program to demonstrate a classic deadlock situation where two threads try to acquire two mutexes in opposite order. So I think that's it for the deadlock. So next recorder, please.
So our next topic is all about starvation algorithm. Starvation occurs when a process is unable to proceed indefinitely because it is not being allocated the required resources. In other words, a process is continuously denied necessary resources, preventing it from making progress. Next. So, causes of starvation. Starvation can be caused by a variety of factors including resource contention, priority inversion, and deadlock. Next. So, what is resource contention? So, resource contention occurs when multiple processes are competing for the same resource. It can lead to resource contention. If one or more processes are granted access to the resource repeatedly while others are not, it can result in starvation of the process that are not receiving access. Next slide. So the second factor that can cause starvation is called priority inversion. Priority inversion occurs when a low priority process is holding a resource that, that a high priority process needs, and a medium priority process requests access to the same resource. This can result in the medium priority process receiving access to the resource before the high priority process, causing the high priority process to be blocked and potentially experience starvation. Next. So the last factor that can cause starvation is the deadlock. The deadlock occurs when two or more processes are blocked, waiting for each other to release resources they need in order to proceed. If one or more of these processes are essential for system operation, they may experience starvation as they are unable to proceed. Next slide, please. So, strategies for resolving starvation. If a process is experiencing starvation, there are several strategies for resolving it, including increasing the priority of the process, implementing a priority ceiling protocol to prevent priority inversion, and allocating resource more fairly. Next.
This block of code includes two header files tdio.h and pthread.h and defines a global variable mutex of type pthread mutexT, which is used to synchronize access to the shared resource. The variable shared resource is initialized to 0. So this code snippet sets up a program that includes the headers files tdio.h and pthread.h, and this defines a global variable named mutex of type pthread mutexT, which is used to synchronize access to a shared resource called shared resource. Next. This function start process is the thread function for the start process thread. It is an infinite loop that repeatedly locks the mutex, increments the shared resource variable, prints the value of the shared resource, and then unlock the mutex. So this function start process is the thread function for the start process thread, and this infinite loop repeatedly locks the mutex and increments the shared resource. And within the loop, the start process function performs the following steps, which is locking the mutex, incrementing the shared resource variable, and printing the value of the shared resource. Next. So the main function initializes the mutex using the pthread mutex init function, creates the start process thread using the pthread create function, and then enters an infinite loop. In the loop, the main thread repeatedly locks the mutex, decrements the shared resource variable, and prints the value of the shared resource, and then unlocks the mutex. It also introduces a delay of 10 million iterations of an empty loop to allow the start process thread to execute. Next. So this is the output. The program will continue to run indefinitely because both the main thread and the start process thread are infinite loops that continually lock and unlock the mutex. Overall, this program demonstrates a scenario where a process can experience starvation if it is always blocked by another process, that continually locks the mutex and does not release it, preventing the block process from accessing the shared resource. Next.
So for the conclusion, um, deadlock is when two or more processes require some resources to finish the execution held by the other process, or a deadlock arises. On the other hand, starvation is when a process demands a resource for execution that is never available, and it is called starvation. And a type of issue, deadlock is more of a distributed design, or better say process design concern, while starvation is more of a scheduling program. Next slide, please. And in prevention, deadlock is allowing preemption and preventing mutual exclusion, circular wait, and hold and wait. While starvation is simply by avoids your starvation by using concept of aging. And supplies, deadlock is requested. The supplies are blocked by other processes in a deadlock. And when supplies are scarce, high priority processes consume them continually, and that's it for starvation. And next is emerging condition. Deadlock is no preemption, mo to sila mga hold and wait, and circular wait, and mutual exclusion are all required factors. And in starvation, conditions like prioritization, enforcement, and unregulated resource management. So that's it for conclusion, and thank you guys for listening.